Hello everyone, I hope you all are doing great. My name is Harsh and this is my presentation on LLMs and how we can host them locally. So first of all, let us begin by understanding what is an LLM. So LLMs are a kind of an artificial intelligence which can understand and process natural language, and it would also give you responses in natural language. I think 99% of us might have used LLMs, and if you are somebody who has not, then you might fall behind in the near future. Like, of course, understanding is important, but we need to adapt to AI in this super fast age. So, LLMs at a very theoretical level are working on predicting the next word of a statement. So, let me explain. Let's say you ask him, "Hello, how are you?" So, it generally says that, "Hi, I am doing great. What about you?" So, how does it identify my intent and how does it give me a response? And that too in again natural language. So, it actually does not understand language uh, as a mode of communication. Under the hood, it's just a very complex series of mathematical computation that takes place, and at a higher level, it's predicting the next word. So, I have said here, by the way, these screenshots are from 3 Blue 1 Brown. So, if you are really interested into AI, I'd recommend you to watch his videos. It's really mind blowing. So, the user gives a statement saying that give me some ideas for what to do when visiting Santiago. And the AI says, sure, there are. So here what happens is that it computes a series of possible words that can appear after the specific word. So it first predicted sure, then a comma, then it says there. After there, these are the series of tokens. What are tokens we'll learn in the upcoming slides, but you can say a word. These are the probable words that it thinks should come after this sentence. So R has the highest probability, so it just prints out R. Then it could print some other thing, name of a place. It will again create a list of probabilities of the next word, and it will show you that word as an output. Again, if you would like to create responses that are not always the same, you can add some kind of randomness in the probability. So instead of R, you could print something else uh, and then something else. So it would lead to a series of statements which are not always the same. So generally, everybody in today's age for LLMs use this kind of randomness, so you get kind of a personalized experience. So there are a lot of terminologies that revolve around LLMs. If you have used or ever visited a platform like Olama or Crew AI or anything, you might have seen after a model's name, there are multiple things like 8B, 128B, and all. So, what are these things? So, generally, the B thing represents parameters. Parameters are weights of a neural network. It can be in millions, billions, or trillions. Uh, I haven't really seen many models with trillion parameters, but generally, parameters represent the amount of information that a model can hold. It can also represent the amount of complex things that model can perform. Although, please note that it's not always true that more parameters means a better model. It depends upon many things such as your use case and the training data of that model will learn everything in depth about what is training data and all. But generally, more parameters means the model is complex. That means that it will take a long time to train that model or perform anything with that model because the size is big, which means the resources used, CPU time or GPU time, would be more. And even if these things are more, then the memory consumed is also more. So, VRAM latency and energy, and apart from all this, the most important thing is also that the cost is more for bigger models. So, this is kind of a representation. This is a very small neural network, so it has only two hidden layers. In the real world models, you would have neural networks with millions of hidden layers. So, 1, 2, 3, 4, 5, 6, 7, 8. So here we can consider that there are four nodes in a hidden layer. There are two hidden layers, so 4 into 4. Around 16 connections are formed here. This is the input layer. It has three nodes, and the output layer has two nodes. So here 16, there are literally 16, and again here you have three. So after each layer, you multiply it by the number of nodes. So you can literally feel that in just two layers that there are so many permutations and combinations possible. Imagine if you have millions of layers, how complex that model would be. And to show that, let me show you something really cool. So this is a model called as Nano GPT, and the parameters that it has is 85,584. Now, by the way, you can also view it in 3D. Let's look at GPT-2. The parameters that it has is 124, 4, 39, 908. Now you can just look at the scale of these two models and just look at the difference. It looks like an ant, and this is like a huge building. But now let me show you something really crazy. Now GPT-2 XL is again so much bigger than GPT-2 small. So the craziest thing is that let's look at GPT-3. So now, if you don't find this cool, I don't know what is cool for you. Just look at the scale of these things. So this is the reason that all the companies are investing in hardware infrastructure and all, because the scale at which these models perform mathematical operations and the scale of compute power that you need to make these models the way they are is so high. Like the nano GPT is almost not visible at this point if you look at GPT-3. So it's really crazy. So uh, again, I'll repeat that more parameters does not always mean a better model. It depends upon a variety of things. So always read about the model first before you download or use any of them. Again, the next thing is context length. Context length is also a popular thing that we all might have heard. So it is generally the memory, you can say, or the amount of things that it remembers from your conversation. Like if you jump into an older chat and you just ask something, it could say that previously you had mentioned this and that. How does it remember all these things? Is because it has some limited amount of context about whatever conversation might have taken place. Nowadays, these platforms provide such memory that across the different chats, it saves your memories and context. So, in chat A, it could use the memory of chat B. So, it's really crazy what these companies do these days. So, it can range from 4,000, 8,000, 128,000 for long documents. So bigger context would mean that it remembers more stuff, but it's not always necessary that having more bigger context would mean a good result, because there are things like hallucinations and all. So if you're really into it, I would highly recommend you to read a paper which is called Attention is All You Need. It was released by Google in 2017, which has so many new things, and it is basically the foundation of today's AI age. Now, let us understand what tokens are, because irrespective of anything that you might have heard or not, tokens are something you'll definitely hear about when you are using an LLM, because often times we run out of uh, credits to use AI for free generally, and it says that you have exceeded the token limit, and please try again after a few hours. And tokens are just small tiny bits of an input that you give to the LLM. It's not necessary that a statement is divided into words, but it can be divided into a set of characters, such as in unbelievable. It could divide unbelievable into separate tokens. Now, how does it do that? So it is all different for every model. It depends upon the companies who make those models or the people who make them. They are the ones who generally decide how the tokens are broken down, because all of these divisions happen as a result of some algorithms. And cost and limit, yes, that I explained already, that the amount of tokens you could enter is limited, and you'll have to pay for more getting more tokens. Embeddings. Now embeddings are again an important thing that we need to understand for large language models. So any kind of input that you give, let's say a statement that I described earlier, hi, how are you? And it's divided into tokens first, but then it's converted into something called as embeddings. Now, LLMs are just, pieces of mathematical functions that perform mathematical computations, and you cannot perform any mathematical operation without numbers. Like there is no meaning of performing operations on a sentence or words, right? So embeddings is like a numerical representation of your tokens. So a token is uh, uh, formed from dividing a sentence, and then you convert that token into a numerical representation. It's generally stored in vector or an array, you can say, and its dimensionality again depends upon the type of model you are using and the people who built it, and it can be used for semantic search, RAG, and clustering. I'll be explaining what these things are. But you need to remember one thing is that these tokens are just uh, numbers that are containing the meaning of those particular tokens. So let's consider an example that we have given some kind of business documentation. So we'll consider a documentation for holiday policies of a company. The document contains huge paragraphs about what are the rules for you to apply for a holiday. And it clearly mentions that you can only apply for a holiday in the month of March, and before that, you cannot apply for a leave. And we convert all this English language document into tokens, and the tokens are converted into numerical representations and stored in vectors. So these are huge pieces of numbers that are stored, and it's stored somewhere, right? So it's a vector database that stores these vectors or numbers. And when you query an LLM, if you have asked ChatGPT that can I apply for a leave, it won't give you the answer for your company. Why? Because it does not know the rules to apply for a holiday in your company. So here is where we can leverage vector embeddings and uh, RAG, retrieval augmented generation. At a higher level, it's just that we store content or knowledge in a vector database, and then we used it, we retrieve it, you can say, for getting a personalized answer. So now, if you have given your LLM or your application access to this vector database of your company, instead of LLM giving any random kind of output or saying I do not know, what the LLM will do is that it will refer this particular vector embeddings, and it will perform something called as a similarity search, which is just comparing the user input, which would be, hey, can I apply for a holiday tomorrow? Now, for me, tomorrow is 9th of February. It's not March. So, according to my company rules, I cannot apply for a leave. So, the question about holidays is converted into numbers, and these numbers are compared to the numbers that I have in my database, and it performs a similarity search. Let's say the sentence of you cannot apply for leave in February, you can apply for a holiday only in the month of March. So this statement would have similar numbers with my input question. So once it had identified the similarity in between these two statements, it will fetch that particular chunk from the vector database, and it will convert it into natural language again, and it will say that, oh, okay, according to the documentation that you have shared, you cannot apply for a leave in the month of February. You can only apply for a leave in the month of March. So you can see that how I have received a very specific answer for my question with my custom knowledge base. So this is why it is very important to understand how these things work. Now, another term on our LLM is transformer. So, coming back to the paper, attention is all you need. That paper had introduced this transformer architecture. Before that, the large language models or AI in general used something called as RNN or recurrent neural network. What RNNs did is that they analyzed every piece of statement one by one from start to the end, and it did not give the output that we get today. Like today's output is very good. It really feels like you're talking to a human being, right? So the transformer architecture at a very high level has these things like self attention, feed forward, networks and layer norm plus residuals. I'll explain you at a very high level. If you are interested in learning about it in low level, you can read the paper. But at a high level, what it does is that instead of analyzing the statement word by word, or token by token from start to the end, it focuses on understanding the meaning or the connection in between all the words in the sentence. So it's not just start with, it will analyze it like everything with each other. If I say a sentence that Sir Henry was a very renowned knight. Now, knight could also mean that the night where the sun goes down, but knight could also mean that these armored people who have these swords and other things. I do not know what, but I hope you get the idea. Even if the spelling is different, they they could have different meanings for different kind of statements. Like if I say that tomorrow night, KNIGST, I have to go to the gym. It would, think the LLM would think that there is a spelling mistake and they mean the night when the sun goes down. But if the word sentence was different, like about Sir Henry the Knight, uh, in this case, the night would mean something entirely different. So it focuses on analyzing the relationship between different words and tokens of your entire uh, input statement or any statement in general. So it requires two things, pre-training and fine-tuning. All the models they require pre-training when they are initially formed. What is pre-training? Let's say you're building a LLM from scratch. So you would require some function that will take input and give output. So initially you can make any kind of function and you'll give it lots of data. Like it's like a kid who is learning to walk. You have to put one leg first, then you have to put next leg first and all. So you learn by falling, right? Similarly, these models also learn by failing. What we do is that we give them a question at a higher level. I'm explaining that we give it a question, we'll ask the model to guess it, and then if it has guessed wrong or if it has guessed right, we'll show them the answer also. So if it has guessed wrong and the answer was different from what it has guessed, it will optimize itself in such a way that the next time you ask the same question, it would give you the right answer. Now, we do not do this for one or two questions, but we do it for a very, very big amount of data. Like looking at that visualization, you might have guessed the scale at which these things are made. So let's say you give it entire internet as input, and you'll tell it that, hey model or the mathematical function, this is all you need to learn, and these are the correct answers. Keep on guessing until you get everything right, almost everything right. So this is the pre-training phase where you train the model on a very massive data set. It can be labeled or unlabeled. Unlabeled means you do not give it the right answer. So it its job is to predict the next token. That's what they do. LLMs do that. They predict the next token or the next word, and the outcome would be that it will understand language and it would store this world knowledge in its parameters or as its parameters. So that's why the parameters are important. Again, if you're working on so huge data, you will require a lot of compute. You will also require lot of time and you will require a lot of energy. And that is the reason that companies these days are investing so much on hardware, computing hardware, and that's the reason all the GPU prices are above the roof right now, because all these companies have already bought most of the stock that manufacturers are going to produce for this year. So you can also use external services like AWS and all. It costs around $12 million for training a very big large language models and a few weeks and thousands of GPUs to do this. So either you can buy it for yourself and spend millions of dollars, billions of dollars, or rent it out from some third party. The next thing is fine tuning. So in fine tuning, you just pick up a pre-trained model, let's say llama, and you'll train it for some specific task. Let's say you are making a project for an AI doctor. So you already have a model who understands English, who can converse in natural language in English, but you need it to be specific about medical details. So what you can do is you will give it a lot of medical data, and this data would be labeled, and you'll teach that model that uh, for medical context you need to answer in this particular way, and you run it again and again. It does not require as many resources as pre-training it from scratch, because you're already building on something that's been made. The foundation has been laid. So you fine tune it for specific kind of data. You can use supervised fine tuning data and domain fine tuning data. And there are providers in this field also who will provide you specific data for fine tuning model. And there are again providers here also who will provide you labeled and unlabeled data for training LLMs. So this is an example based on transformer architecture. You can pre-train a model from scratch, and these are some the data sets that you can use. You can consider the entire Wikipedia or GitHub repositories, which are public, and data created by these companies. And you can create a pre-trained model, Llama, you can say, which is made by Meta. They have invested millions of dollars to make the model, but you can also use some pre-training data and create a model like Alpaca, which is not requiring as many resources and as much money as you would require to make Llama model, because on the back end it's just using Llama model fine-tuned to answer in some specific way, and it has extra knowledge of some special things. That is all. Let's learn about GEMMA. GEMMA is a series of lightweight models which are, sorry for that, uh, GEMMA is a series of models which are similar to Gemini, but they are open weight, first of all, and second is that they are not as big or as complex as Gemini models. So, it is an LLM family by Google. It was built from the same research stack as Gemini, but smaller and local friendly. Local friendly is important because that is the topic of today's presentation. So, these are a few models, or these are not Gamma models, they are on the next slide, but these are some models which are made by Google, and Nano Banana everybody might have used by now, I think. And Gemini, again, everyone knows. These are some other models which are really good. I've tried some of them. So let's talk more about Gamma. Let me show you some Gamma models first. These are a few Gamma models that you can download from where I'll come to that. Now, let's see what is Raspberry Pi. Raspberry Pi is a low cost. Do we have time? Yes, we have time. So, Raspberry Pi is a single board computer in the best way that I can say. It's basically an entire computer. You just need to attach some networking content like an Ethernet, or you can use Wi-Fi. You can provide it power supply, and you need to give it some kind of storage. Connect your keyboard, mouse, and monitor, and it's an entire computer. That is all about Raspberry Pi. But let's see in a bit more depth. It is very small, a credit card size computer. It's amazing, and it's ARM based. ARM is an instruction set type. We don't need to care about this, but we always need. It's always good to have knowledge. So there are x86, then you have x64, which is an advancement of x86 instruction set. Basically, all hardware have a specific syntax of taking in instructions. So these ARM x86, x64, and all are kind of instruction sets. Like C has a different syntax, Java has a different syntax. You can say it is kind of like that. It can run Windows also. It can run multiple operating systems. The general default operating system, and one of the most preferred ones, is Raspberry Pi OS, which is an operating system made for especially this kind of hardware. It You can give it micro SD card or attach hard drives and SSD to it. It has everything, networking, display output, power supply support, and all. It requires specific amount of power. We'll see it in the next slide. And you can use it for IoT and embedded systems. You can use it for edge AI, which is a topic. Automation and robotics also. It is cheaper than an actual computer. It works on very low power. It is a full computer, not a microcontroller like ESP32 or Arduino Uno, Arduino Nano, anything. And how we can host LLMs on Raspberry Pi. So, in general, what happens when you use ChatGPT is that you type something, you press enter, an API call is made to OpenAI, because ChatGPT is not an open source model, it runs on OpenAI servers maybe, and you cannot see or use the model for yourself. You need to pay them, pay OpenAI if you want to do so. So the computation takes place somewhere else on the cloud, somewhere else on the internet where you cannot go. And in the AI, what happens is that you have full control. The model could be created by you. You can use some open weight, open source model like GEMMA, and you host it yourself, and it can work offline. That's the best thing that I feel about it because it's on your own network. So all the computation takes place on your edge device, such as Raspberry Pi. You can use it for multiple things. We'll see how we can use it for Liquid Galaxy. So you'll need a stable power supply. This is just a list of different kind of input power that you can give to different Raspberry Pi models. And first of all, you'll need an operating system because Raspberry Pi is like a credit card, but it's small, but it's hardware. To interact with hardware, you need software. So that's an operating system, a software used to interact with hardware. Raspberry Pi OS is a default choice for that, and you can install it by burning it on an SD card or any other storage space. Burning and all is a process of like loading some initial pieces of software for installing the entire operating system, storing it somewhere. So the time you enter your SD card in it and boot the Raspberry Pi, you will get some kind of interface. All this content comes from burning it onto an SD card. So once that is done, you can install the entire operating system, choose the options that you like, and after downloading the image and installing it on your computer, you can use uh, to select the operating system and all. And after that is done, we'll use SSH again. In this case, I have made an entire presentation earlier about how SSH works in extreme depth. I think someone else has also made a video about SSH, so you can watch these videos from the contributors. And once the Raspberry Pi operating system is installed, you can set up SSH access to Raspberry Pi. So you can use something like your mobile phone to connect to your edge device, which is Raspberry Pi. Now, this is what Raspberry Pi OS looks like. It's very nice. I like it. And this is how you can configure SSH. So this is just a screenshot of the configuration page. You can set the host name, password, and serial set identifier. Well, this means the name that appears when you look for available devices. Then uh, use password-based authentication, use public private key access. I have explained everything in my first or second presentation that's on YouTube. So you can configure SSH and then you can directly access your Raspberry Pi using a remote device. To use an LLM on Raspberry Pi or in general on any device locally, Olama is a very preferred piece of software. So it is an open source tool which is designed to run LLMs locally on your computer. We can directly download it. This is a Linux command to visit this URL and install something. So you can use Olama pull to download model. I have Olama on my system also. Let me show you how it works. Olama list. It's slow, but it works. Okay, by the time that loads, let me explain you. You can use Olama pull as a command to download different kind of models that Olama has. Most of these models, almost all of them are open source. That's why you can download it and run it locally for free. So it's like unlimited access to an LLM because all the computation happens locally on your own device. So if just by doing this, like Olamaran, I'll show you. So these are the models that I have. Let's say I want to run this model. So I'll type Olamaran GEMMA 2B. 2B is 2 billion parameters. It's a lightweight model. You can see the size is 1.6 GB. Once you press enter, it's loading the model. Let's wait for it to load. Let's go to the next slide till that time. So this is a screenshot of Raspberry Pi OS running on a model locally. This is again a syntax to access the model and share your prompt remotely. Explain here briefly. So let's try running it. Let's wait for it to load. These are some models from Olama that you can download for specifically GEMMA family. So you can see GEMMA 2B is around 1.7 GB. 7B is 7 billion parameters, is 5 GB. So you can observe that as the size has number of parameters has increased, the size of the model is also increased. There are, I think, 300 billion parameter models so that are like 175 GBs, and they will blow up your computer if you run it. You need very, very high-end machines to run that model. So how we can use it for Liquid Galaxy? Let's see. My model has booted up now. So everything is running here offline and locally. What was the question that was asked? Explain AI briefly. So let's ask it the same thing. Explain AI briefly, and it will again generate the output locally. So and you can see how it's creating one token at a time. It's generating tokens and tokens and tokens. You can look at it creating stuff, and it has explained AI briefly. I'll say bye. And it exits. So this is Olama. Nowadays, Olama also has its ChatGPT like syntax that you can use, but I always like the terminal version more. So how we can use it for Liquid Galaxy? You can first use it for natural language exploration, which is like you will just have something like Jarvis, but for Liquid Galaxy. This is also one of the projects this year. At least the proposed projects we do not know until Feb 19th if they'll be there or not. But yeah, so you can use it for natural language exploration. Like you can just say, show me earthquake play prone zones for Japan, and it will render a KML and fly to that specific location on your Liquid Galaxy rig. You can use 3D KMLs, polygons, everything. So you can just say it out or type it out in natural language. The LLM will analyze your input and accordingly give you some kind of output like AI guided narration, local Q&A explanations and all. And again, the best thing that I said is that everything would work offline since you, Raspberry Pi, Liquid Galaxy are all together on the same network. So you do not need internet access. And you can use it for voice control navigation speak, and you will have a GEMMA model running on Raspberry Pi, and it will perform different actions that we say or we have explained or we have taught it to perform. So this could be a rough flow, which is your voice is going to GEMMA LLM via mic maybe as an input, and the processing takes place and it gives a structured KML output on a Liquid Galaxy machine or Liquid Galaxy cluster. So this is how you could have used Raspberry Pi or Edge AI for Liquid Galaxy, and it is a very high level overview about all how LLMs also work. I hope you learned something new, and bye bye.